Chapter 5, Discrete Probability Distributions. And when we're looking at discrete probability distribution, what that means is that we're looking at whole numbers. Once we get to Chapter 6, we're going to learn about continuous probability distributions, and that's when we include all the decimal, all the scenario as well. But for Chapter 5, we're looking at whole number, we're looking at discrete number. So what we're looking at is the probability of individual whole numbers. And in addition to learning discrete probability distribution, we're also going to learn about binomial distribution and Poisson distribution in this chapter. So discrete variable, we learned that in Chapter 1, discrete variable produce outcome that comes from a counting process. So that's Chapter 5, and in Chapter 6, next class, we're going to learn about continuous variable, continuous distributions. So continuous distribution is when we produce outcome that comes from a measurements. So that's the difference between discrete and continuous. And when we're looking at the probability distribution for discrete variable, you need to know how to calculate the mean, the variance, and standard deviations. Mean is basically your E of x. E of x represent your expected value of x. So that's what the E of x is. So your mean is basically your expected value, what you expect to get. And the formula for the mean is basically the sum of all the x times p bracket x equals to x. So x is basically your x, and then p bracket x equals to x is basically your probability. So what we're doing is that we have x times the probability. So we have each of the x value times is probability. Once we do that, and then we're going to add them all up, and that's your mean. That's your expected value. So we take all the x value, we times it by the probability, and then we add them all up, and that will give you the mean. That will give you the expected value. We're going to go for example 1 right now, and I'll show you how to calculate the expected value or the mean in Excel. Example 1, given the following probability distribution, find the expected value, the variance, and the standard deviations. So in the question here, what we have is the interruption per day in computer network, and then we have the probability. So your interruption per day, which is your column B, that is your x. So these are the x value. So the x value we have from 0 all the way to 5. And then we have in column C, which is your probability. And to calculate the mean, what we're going to do is we're going to take each of the x value, we're going to times it by the probability. So probability is p bracket x equals to x. So we're going to take each of the x value, we're going to times it by the probability. So what we're going to do for the first number is 0. So what we're going to do is take the x is 0. So 0 times your probability. So what we're going to do is we're going to take the cell B6, we're going to times it by the cell C6. So B6 is your x, and then C6 is your probability. So we take the x times the probability. So that's for the first cell. We do the same for the second cell. Second cell is basically your 1 times your 0.25. And how we're going to do that is we're going to replicate the formula in Excel. So bottom right corner, you'll see that there's a black cross when you hover over the cell. Once we see the black cross, we just hold it and then drag it down, and we can replicate the formula in Excel. So you can see that for the next cell, what we have is 1 times 0.25. So the 1 times the probability. Next cell, we have 2 times the probability of 0.2. So we have 3 times 0.01, and so on. So again, the key is to set up the formula once and then replicate it. That's the key. So set up the formula once. We set up the formula once. We take the x, and then we times it by the probability. Once we set this up once, then we can replicate the formula. We can replicate the formula by going to the bottom right corner. We see the black cross, we drag it down and replicate the formula. Once we have the x times the probability for all 6 of them, what we're going to do is we're going to sum them up, we're going to add them out. And what we're going to use is the equal sum formula, equal sum open bracket, and we're going to highlight the data set from D6 to D11, equal sum D6 to D11, we close the bracket, and that will give you the 1.4. And that is your mean, that's your expected value, 1.4. Next, we're going to calculate the variance. Variance is similar. What we have is a summation sign here, so summations. And then what we also have is the p bracket x equals to x. P bracket x equals to x just equals to your probability. The only thing that is different is that now our x is not x anymore. Our x is x minus e of x squared. So that's the difference between the mean and the variance. We don't have x, we have x minus e of x squared. And basically what that means is that we have the x minus e of x. E of x is just your mean. So x minus the mean squared. So for variance, what we have is that for each x value, what we have is that we take the x, we minus the mean, and then we square that value. And then afterward, we times it by the probability, and we do it for all the cells. Once we have done that for all the cells, then we sum them up, and that's your variance. And then what standard deviation is basically the square root of your variance. So once we calculate the variance, we just square root it, and that will be your standard deviations. So I'll show you how to do that right now. So right now, I'll show you how to calculate the variance and standard deviations. So the formula for calculating variance is basically x minus your e of x, which is your mean. So x minus the mean square times the probability. So this is what we have set up in here. X minus the mean square times divided by the probability. So x is column B, and then probability is column C. And then our mean is 1.4. So we're going to put equal and then open bracket, and then we're going to take x minus the mean. So we're going to follow this formula here to set up the equation. So x minus the mean, x is your column B, so 0, which is your B6. So B6 minus the mean is 1.4. And what you need to know here is that because we're going to replicate the formula, when we replicate the formula, we want the 1.4, we want the mean to stay constant. Because the mean is 1.4, we want the mean to stay constant. So that's why we need to lock in the mean. And how we lock in the mean is we press F4 on your keyboard. So when we press F4 on the keyboard, you'll see that there's a $sign in front of the E, a $sign in front of the 14. And that's what we call absolute referencing. And by doing the F4, by locking in the mean, what it does is that when we replicate the formula, the mean will stay constant. The cell E14, which is the mean, will stay constant. And that's what we want. And then we're going to close the bracket, and then we're going to square that. So to the power of 2, so half 2. Once you squared it, we're going to times it by the probability. So times it by the probability. Probability is column C, which is your C6. So once this formula is set up, then we can replicate the formula. We can replicate the formula by dragging it down. We can see that there's a black cross. Once we hover over to the cell bottom right corner, we drag it down. And then you can see that for each cell, we have the x value minus the mean, which is the 1.4 that we locked it in, square, and then times it by the probability, which is column C. So for 2, for x equals to 2, we have B8 minus the mean times the probability, which is the 0.2, and so on. Once we calculated this, then what we need to do is sum them up. We need to add them up. So equal sum, open bracket, and then we highlight the cell, E6 to E11, and that will give you the 204, and that's your variance, and that's our variance calculations. Once we calculated the variance, then we can calculate standard deviation by just taking the square root of the variance. So the formula for square root is SQRT, so equal SQRT, open bracket, and then we're going to square root the variance, the 2.04. So square root cell E18, and that will give you the standard deviation of 1.428. And that's example 1.